Welcome back. This is going to be continuation of our lessons about implicit differentiation. That means finding a derivative of an equation where the equation is not in explicit form like y equals a function of x, but it's in this implicit form and it is implied. I'll write it again. It is implied that the variable y is standing for a function f of x. In some cases, it's standing for multiple functions because the equation you have does not draw what we would call a function that would pass the vertical line test. You might have to break the graph up into multiple parts, and each part would pass the vertical line test. But in implicit differentiation, we don't have to know that. We just have to treat the variable y as if it were a function. So when I differentiate anything with y in it, it's always a function within a function, and we use the chain rule. If we're differentiating a term with x, we differentiate as usual. So I have an equation here, 16x squared minus 32x plus 9y squared plus 54y equals 128. The instructions today are find the points, and it's going to be written as an ordered pair, where the graph of this equation has a horizontal tangent line. So remember, that would mean that the shape of the graph would be such that the tangent line is horizontally straight across, and that means that the slope, or in other words, the derivative, must equal a zero, because zero is what the slope of a horizontal line is. So essentially, we're going to be solving for the derivative, and then solving for at what value, at what ordered pair would the derivative equal zero. Okay, so the first step is to calculate the derivative by first differentiating every term. So I'm just going to go left to right here, and the derivative of the first two terms, they're both involving just x, so they are just standard derivatives. The derivative of 16x squared, we'll use the power rule, 32x. The derivative of minus 32x will be minus 32. And now in these next two terms, your thinking is this is like 9 times f of x squared, and that derivative requires the chain rule. So we differentiate as usual, like 18y to the first, but then we must multiply by the derivative of our function. So we're going to multiply by y prime. The derivative of 54y would be 54, but because y is your function, we multiply by the derivative of that function. So the derivative of 54y is 54y prime. And then the derivative of 128 is 0. And so now we're left to solve for y prime. Well, it appears in two terms here. So I'm going to leave those on the left side, and I'm going to move the other two terms to the other side by subtracting 32x from both sides and then adding 32. So my derivative, or my left side now, is 18y times y prime plus 54y prime equals negative 32x plus 32. So now is where I factor out y prime and have 18y plus 54 equals negative 32x plus 32. So I'm going to get my y prime by dividing now, and I'm going to get the expression negative 32x plus 32, and that's all going to be divided by the quantity 18y plus 54. So that expression calculates the slope of any point on this graph, but I in particular am asked to find which points have a slope of 0, making the tangent line horizontal. So we want to solve, when does this derivative, negative 32x plus 32 over 18y plus 54, we want that to equal 0. Now, I have a fraction that I want to equal 0. So if you know a little bit about how fractions work, a fraction would have a net total of 0 if the numerator was 0, but the denominator was something other than 0. Like 0 over 1 is 0. 0 over -5 is 0. Okay? So essentially, the shortcut to this answer is to note that we want the numerator to equal 0. Okay? So that becomes a simpler question. When does -32x plus 32 equal 0? And that's now an easy two-step equation. -32x would equal -32. I'm subtracting 32 from both sides. And x is going to be +1. Okay, so we're most of the way done. I now know that in the answer to the question, I'm going to start putting the ordered pair up here. The ordered pair has a 1 for x, but I still don't know y yet, the y value. But I have, remember, the point has to be a point on the graph of the given equation. So that's where I'm going to find the y coordinate, is I'm now going to substitute for all the x's. I'm going to substitute 1, and I'll solve for y. Okay, so it's going to be 16 times 1 squared minus 32 times 1 plus 9y squared plus 54y equals 128. This is 16 minus 32. So all of this just makes 16 minus 32, which is minus 16 plus 9y squared plus 54y equals 128. And so now the question is, we have to come up with a plan to solve this equation. Well, just examining it, this is a quadratic equation in y. So we're going to get it all in standard form and attempt to solve it in one of the ways that we know how to solve a quadratic. So we need to get it all equal to 0. And I'm just going to put it in standard order, which means I'm going to start the left side as 9y squared plus 54y. And then I'm going to combine -16 and subtract the 128 from both sides. And doing that calculation, I get minus 144 equals 0. So now we're charged with solving the equation 9y squared plus 54y minus 144 equals 0. If we're lucky, it will factor down into nice solutions, but if we try that and are unsuccessful, you could always use the quadratic formula, or you could, on your graphing calculator, graph this and find the zeros. Okay, when you graph it, you'd have to replace the y with an x to do it, but otherwise the principle is the same. But I noticed that every term in here divides by 9. So I'm going to start by dividing by 9 and make this y squared plus 6y minus 16 equals 0. And now I notice that does nicely factor down. So it's going to be y plus 8 times y minus 2. And solving each of those equal to 0, my y is either -8 or y equals +2. So that tells me I actually have two ordered pairs. One of them is going to be 1, -8. And the other one is going to be the ordered pair 1, 2. They both count. Okay, so to check this, I've already gone ahead and in Desmos, and you can do this on your Desmos app on your iPad, you can type this implicit equation and it'll graph the curve, and we can inspect that these 2 points would have a horizontal tangent line. I'm going to go ahead and pull up the Desmos screen for us all here. And here it is. I've gone ahead and I've typed in the equation in the command line here. 16x squared minus 32x plus 9y squared plus 54y equals 128. And it drew an ellipse. Maybe you recognize this type of equation from algebra class, but if not, it's okay. Here's the graph of the ellipse. And notice, here's the point 1, 2. And it definitely is at the top where the tangent line would run horizontally. And here's the point 1, -8. Also, the tangent line runs horizontally there too. So I believe we have the correct solution.